I simply wanted to open a program that is kind of a little bit along the path where we're going with our program. Some of you may have gotten yours further, some shorter. Some of the videos I make, have these same classes and the same functionality, either going further along or shorter. I just wanted to set up a program where we can use the matrix transformations in a program and kind of just look at what they look like. And so I'd like to just do this live and set up, little movements and motions and stuff that we want to see happen, and just figure a little bit out how we do it. Since I know we've been kind of drawing on the whiteboard a lot of these matrix transformations, how they work, how the math works, but apart from the videos that I've posted online, we don't really have this reference to what actually happens. So just have a bunch of stuff here. Most of it you'll know. What I do have in this particular program is I have kind of two main things that I'm going to set up from the get-go. I have these classes matrix and model matrix. And the matrix class, I think, is just exactly like the matrix class that I've already put online. What it has is it has the function to load an identity matrix, which does just that. Just kind of neutralizes our matrix. And it has add transformation, where it takes in another floating point array. And there's just this huge block of math here. And the idea is simply it does what a matrix multiplication does. It's a 4x4 matrix times a 4x4 matrix. So it's 16 different numbers, and each of them has kind of 4 multiplications added up. So you can see that for each of the 16 numbers here, we have something times something else plus something times something plus something. And this is just a correct matrix multiplication. So it's nice to already have that. So because setting this up in a program is mainly just making sure that all the numbers are correct. It's not a complicated thing. It's just big. And then it's kind of put in the matrix. It's not necessarily the best optimized way to do this, seeing as in most of these multiplications, the last 4 numbers are just 0, 0, 0, 1 anyway, so we wouldn't really have to check those out, so on and so forth. But for the sake of just doing this correctly, this is just the entire thing. So add transformation that takes a floating point array, add transformation that takes a float buffer and does just exactly the same thing, just the array is on another format. And then we have this functionality here, push matrix and pop matrix. So what they simply do, and this is actually a very bad optimization of this, since we're newing kind of a new matrix every single time and putting it on a stack. What would be nice for those of you who want to do is to actually say, I'm going to make some kind of stack object that just has already a bunch of arrays in it. And just imagine, okay, I'll never go more than 10 deep or something like that. And just have preset 10 matrices in an array. And then when you push a matrix, just take a pointer that points to where is my stack at now. It starts at 0, then it goes to 1. So just raise the stack by 1, and then take the matrix in that location and just override its values. Does this make sense? This means that the values are already there. We're never kind of adding new objects and taking them off constantly. In the end, if you use this a lot the way it's programmed in here, you will start to see kind of short stops in your program. You'll see your program kind of running, and then there will be this short delay, like 1 frame will freeze for a split second, and then it'll continue. And what's happening there is simply the Java garbage collection is going on, because we're newing, and there's no delete in Java. So we're just newing new stuff, and then we're just leaving it behind constantly when we throw it off the stack. And every once in a while, the Java garbage collection will have to pick all that junk up. And so we'll get these little, so, you can call it my fault or whatever. This is just a very clear way to program what it is doing, just so we know what the functionality is. For those of you who want this better optimized, definitely make the stack implementation better. That is, this is just a stack and newing something and putting it on it. Instead, just put a bunch of stuff on it and overwrite the values inside the matrices, so you don't have to put new matrices and throw them off constantly. All right, so that's the matrix. We have model matrix here. So model matrix simply extends matrix. So it has all that stuff. What it has as well is it kind of imitates this representation of a coordinate frame. So we can get these specific numbers from the matrix. If we look at the matrix itself, okay, I don't have any function where it's set up in that way. So we can just kind of draw it here. Let's do the one note thing a lot of you know from. Yes, exactly. From data structures. So where were we again? Here. So what we basically have is we imagine this is a 4x4 matrix, but it's actually represented in an array. It's in a single 16 value array. And so the numbers are in this order: 0, 1, 2. These are the indices: 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So these are the indices into the 16 value array that will then be represented by OpenGL, if we send a floating point buffer like that in, as a 4x4 matrix. Meaning that if we jump in here, for instance, and we can go into the model matrix, we can see we're taking numbers 0, 1, and 2, which means that's 0, 1, and 2. These are the x, y, and z values of kind of the first vector of a coordinate frame. Or we can imagine it as the x-coordinate vector of the coordinate frame. Then 4, 5, and 6 are the second vector, or b. 8, 9, and 10 are the third vector. And 12, 13, and 14 are the point of origin, the position of our coordinate frame. So this representation we can get here. Get A means just get the first vector. Get B, get C. We can use that to know kind of in which direction things are oriented. In some cases, get C and then make it negative can be the direction something is pointing in, the direction something is looking in. And get origin here, 12, 13, and 14. That just gets the position of a coordinate frame. So then we have, these are kind of the main things here. Add translation. What we would do is we would go ahead and we would make a matrix that looks like this. So we're taking these values, or the names of the values here. Tx, Ty, and Tz. If I lost the draw tool again. So then we simply would make a matrix where we take Tx, Ty, and Tz and put them here, and the rest is just identity matrix. And then we would take this matrix and we would multiply it with the current matrix. What I've done in this implementation, I can probably, no, isn't it control scroll to bigger? Never mind. Hope you can read this. What's being done here is we're just taking the values that will actually be affected by this, and we're changing those. So a translation will actually only affect these three parts of the new matrix, but we're doing the full calculation on those. So we're taking into account the entire matrix, the entire current matrix, and we're using that to update the new point of origin regarding this. But the idea in every case, like add scale here, then we make a matrix that simply looks like this. We have a matrix, we have Sx, Sy, Sz, and the rest are zeros. No, we've seen this before. We make this matrix and then we do a matrix multiplication with the current matrix. And we can see as well that these are the relevant parts that will be affected by this here. Okay, so translation, scale, rotation z, then we actually just make that matrix. We can see, put the cosine, the minus sine, sine, cosine, the rest is an identity matrix. And then we do add transformation. And remember that add transformation is in matrix, and it was this part that just does a full matrix multiplication. Okay, so we have this matrix class. Any questions regarding this as such? Yes. The matrix class is available on Canvas. I'm wondering if the model matrix is probably not, but I make it in one of the videos. Build it from scratch in one of the videos that are online, so you can follow that if you don't feel like implementing it all on your own.
If you wanted to do 2D, would you just get rid of the bottom, like a bottom row, or?
If I want to use this in 2D, what I'm going to do now is I'm going to use this in 2D.
Okay.
I'm actually going to use the full 3D version of the matrix classes. I'm just going to ignore the Z coordinates a lot.
Okay.
But you could also make a new matrix class that is 3x3 matrices.
Okay.
I assume that we will be free to and probably encouraged to optimize this as we can.
Sure. Okay. Just make sure that it works. Make sure that it works in a way that.
Your matrix product isn't already implemented.
This here, so the matrix class, this is completely implemented. So you will have access to this. So the matrix product itself, yes, it is implemented. I felt that was not something I needed to have you kind of doing in your hands, possibly making one wrong number and everything will be off and no one will know why. So yes, I give you this matrix class. The model matrix class is kind of a class that does this specifically for the model matrix, doing the translate product, or the translate transformation, the scale transformation, the rotate transformation. Yeah, and if you watch some of the videos, we'll go a little bit further with this. I have add rotation Z here and Y. Some of it will implement the add rotation X as well, and add rotation like for a general vector. You can find those in the videos, and I'll make sure that you have access to everything you need once we get into 3D. Add rotation with a quaternion, stuff like that we don't necessarily need to go into the implementation of, but can be nice to be able to use. All right, so these are the matrix classes. And the idea behind them is that they simply store these values, or the matrix itself stores these values in a float buffer. Let's see. Yeah. And it has this floating point array here as well, where it can store values. It's used mainly for kind of temporary values and stuff stuffed in there, making calculations. So no worries about that. What it has as well is it has this shader matrix pointer in order to be able to, let's see, is that not used in this version? For the set shader matrix. Okay, I'll look at how I do that in this case, because the other thing I have here is this class graphics environment. So if we go into the game class, I've kind of stripped it of some of the stuff that's down here, and you can see clear model matrix and set model matrix translation and set model matrix scale are not used. I can actually wipe them out. I just wanted to leave them in here for a while, so we can see that I've taken these and I've moved them into this class graphics environment, and I'm actually commenting them out here in the end as well, because I'm using the matrix classes instead. What I have here in graphics environment is a bunch of static functions like set window and set color. So this line here that a lot of you have used, which basically tells OpenGL there is a variable in your shader, and I have a handle to it, and its handle is this color location here, color lock. I want to set its values to these 4 values. So there's a vector somewhere in your shader program, and I want to set its values to this. So the shader program itself if we look here into the vertex shader, is we have this uniform vector with 4 values that's called u_color. And we use this value here to do all kinds of things. It doesn't matter at this point exactly what we're doing inside the shader program, just that we know that there are certain values that are set in our shader. So I have this value, I can use that, I can use it in my shader program. The way for me to set values to this variable, I do it through the program here. Okay, that's not. Let's say we did. So I can call GL uniform 4f. This function simply says I am going to take a uniform variable in my shader and I'm going to set values to it. So the color value is not something that's changing between vertices. It's just a value that I set whenever I want to set it. When I later want to draw in a different color, I set it again. So it says this handle, color location, which has already been kind of connected with that u_color. And then I say these are the values. The values are sent in here, RGB, and then I just set 1 for the last one, the alpha value, which we'll worry about later. Okay, so what I've done in graphics environment is I've simply taken this, which looks a little bit complex, and I've encapsulated in this set color, which takes 3 floats. So anywhere I want in the program, I can now call, like I do here in display, I can go ahead and I can call graphics environment.setColor, and I can set it to whatever color I want. Graphics environment set window. So I've encapsulated set window here, which again, let's not worry too much about what's happening in that matrix, but it's code that I had already given it. Just taking it outside of that. Okay. I've just taken it out. I should just unplug my entire internet here while I'm doing this. So yeah, I've just taken this code that was to set the window. I think in one of the lab assignments, I told you to kind of take it outside and put it into a separate function. Now I've taken that and put it into this graphics environment. And once we get more and more stuff and more variables that we need to set in the shader, it's nice to have something like graphics environment or a class called shader, which kind of encapsulates all of this functionality. So we can just anywhere we want say, okay, now I want to change the model matrix. And so I call this encapsulating class and say, I want to set a new model matrix. For instance, I have this function here, which is called set shader model matrix. And it takes in a variable of the type model matrix. And what it does, it says I have this model matrix location, which is the variable to a 4x4 matrix in my shader. And again, we can look at that in the shader. You can see I have this u_model matrix here. mat4 means it's a 4x4 matrix. And I use this model matrix to multiply with the position that I get in to basically make a new position, which is now in global coordinates. So this line here is me switching from local coordinates, which I get in here through a position. So I set a position x and y, and then I put a 0 in here because this is a 2-dimensional shader, so I'm just wiping out all the z values. And once I've done that, I have a 2-dimensional local coordinate, and then I multiply it with the model matrix and get a 2-dimensional global coordinate. So this value I've changed, the model matrix I change if I want to draw in a different place. Okay, yeah, it always opens the shader outside of the environment. Either way, good enough for now. So I simply take m.matrix, which is the actual floating point buffer within the matrix class, and I send that down into OpenGL and it understands it. So that's nice and clean. Questions regarding this? We'll just see as we go along how I'm using this graphics environment. So I spent a lot of time here just kind of recapping code a little bit. I want to spend more time actually getting things to move around and drawing stuff. So definitely let me know if you feel that you don't properly understand kind of where we're at, or if there's something I use and you feel like I haven't really introduced it, we can look at that again. Can you read on the screen, the ones of you who are actually here?
Yeah.
Because I've forgotten how to resize the text. It used to be really quick, just control and scroll, but sorry? Yeah, I tried that as well. Control plus and control scroll used to work, but something's not happening here for me. Anyway, you complain if it's too tiny, and I hope those watching it online just have it in a nice
All in HD.
yeah, HD full screen mode. Okay, so I'm using this mainly in the display function. We can see that the create function is still the way it was. A lot of code here that we don't necessarily know what's doing, but we will know what all of this is doing as we progress in the course and understand the shaders better. And we'll move this out of here as well into separate shader classes and stuff like the graphics environment is now. Yes.
So we will do some shader programming.
Yes, we will do shader programming. At the very least, to the point that we make the shaders just work like the static pipeline works. But you can go ahead. I have had projects like in the third or the last programming assignment, the big assignment, where people go further into the shaders and implement like multiple texturing and things like that, and transparency and fog and interesting stuff into the shader. So we will do some shader programming, yes, but it depends on individual students if they take shader programming far or if they just go to the point where they understand the very basic shader. Either way, so we have here the classes box graphic and circle graphic. We've done those in other videos and in lab assignments. The way I'm setting them up now is I'm not creating them with kind of the identity of the shader so they can themselves like put stuff into the shader. Instead, I call create on them. So if you look at box graphic, for instance, what create does is it fills a single vertex array and it makes a vertex buffer. Okay, so now it has a vertex buffer with these values in it. When I call draw, it calls the graphics environment to get the location of the vertex buffer in the shader. So position location, if we go all the way through this, we can see that we have graphics environment position location, calling something called OpenGL get attribute location, which means there's an attribute value called a position. I want to link, in this particular rendering program, I want to take that variable and I want to link it or get a handle to it into this integer value. Makes sense? So now I have a handle to it, and whenever I want to put something into that variable, I can say, here's the handle to that variable, and here's the values I want to put in there. Except when it's an attribute, as opposed to a uniform variable I just put stuff into, and then the values of that variable are that from then on until I change them again. An attribute variable is a variable that will be set through a list. So when I run OpenGL with a list, it'll set a bunch of values into that variable, run the shader, set the next set of values into it, run the shader, set the next set of values, so on and so forth. That's what an attribute is. So here in box graphic, I say I'm going to set an attribute pointer. So I'm going to set the attribute pointer for the position to the vertex buffer. So my vertex buffer here is now, these numbers, is now what OpenGL will go for when it wants to find which vertices it's supposed to draw, which location it should use. And if we look at the location here, or the position, this is simply the XY coordinates of the variables, of the vertices that I'm sending in. So a position is simply the particular vertex I'm drawing now is in this position. And you can see how I'm using it. I'm using the X and Y values from it because it's 2D, and then I'm just multiplying it with the model matrix, doing all kinds of calculations here. So basically transforming it using the model matrix, and then continuing on to something in the vertex and the fragment shader later on. Again, this. Okay, so that's what That's what box graphic does. When it draws, it tells OpenGL, this vertex buffer is what I want you to put into the variable that position lock points to in my shader. And then I want you to draw. And I want you to start at index 0 in this vertex buffer. And I want you to draw 4 vertices. Because we told it to take 2 and 2 numbers together, 4 vertices means all these 8 numbers. If I would have put the number 3 in here, this would now be 3-dimensional. It would take 3 and 3 numbers together here and call them x, y, and z coordinates. All right? Now we're working in 2D, so we're taking 2 and 2 numbers together. So what OpenGL will do now, it'll start at 0. So it'll take the first vertex, it'll send that into the shader, and it'll run the shader program. And running the shader program simply means running this main function. So it'll put the values into this variable, and then it'll run this main program. Once that is run, it'll take the next vertex, put those values into a position, run the program, and so on and so forth. Are there questions about this? Just kind of looking at the shader here, how the vertex shader works and how we actually send numbers into it, how it's run. If not, let's continue. Okay, so this is what box graphic does. Circle graphic is exactly the same. That is, draw a solid circle here, does the same thing, except it uses point count here rather than a fixed 4, because it depends on how many points we have in the circle. And the point count depends on how kind of exact we want the circle to be. And there's a little bit more complex ways of actually putting the vertices in. They're calculated using sine and cosine, but I go through all of that in one of the videos as well, if you want to look at that in more detail. But then it simply puts the vertex buffer into the position location pointer, and then it runs it with triangle fan. If it's outline circle, it runs it with line loop instead. And you can go ahead and test all these things back and forth. Line loop, triangle fan, triangle strip, triangles. It'll all look different. All right, so back to the game. We're back to the main program here. So I've created these here in the create function. So I've made sure that the vertex arrays are ready and I can use them to draw. I've newed the main model matrix. If we go into model matrix here, I just have this public static model matrix main, meaning it's kind of a singleton instance of the model matrix. So anywhere I am in the program, I can always say model matrix.main, and I'm referring to this particular instance of a model matrix. It's not a static instance, but it's the instance as such doesn't have static variables, but it's a static instance. So we're always using the same one. So in here, we can go back to display. I'm going to see exactly what I'm doing here. Okay, this is all just 0, 0. Let's see what this program looks like at this point. Okay, so this is what my program looks like. What's happening in it, in the display function, is we're translating to somewhere and scaling, but the scale is really just 1, 1, 1. So nothing happening here. We're really translating to 0, 0, 0 and scaling by 1, 1, 1, which makes no difference. So the main thing we're doing is we're setting the model matrix. Let's leave this out as well. We're setting the color here, and then we draw a solid circle. And this color is the red color. Then we set this darker red color, and we draw a box. And then we set this kind of yellow color, and we draw an outline circle. So the result is this. Nope, that wasn't supposed to be the result. Let's set this model matrix then, anyway, just to have something in there. Okay, so first we drew the red circle, then we draw the darker box, and then the yellow outline circle. And we can change all these things. For instance, we have clear color here. We can change that in order to have a different value on the background. So now we have a blue value on the background. We can go in here and do set color, and we can change these colors around any way we want through the graphics environment. All right. So on to the usage of the matrices themselves. So what I'm doing here, set shader matrix, is I'm just taking whatever's in the model matrix, which is now an identity matrix, and I'm putting it into, basically putting it into the, into the values of the variable for the model matrix in our shader. So that's what the graphics environment set shader matrix does. Model matrix location and takes the shader matrix from there. All right. So what we used to have were these functions set model matrix translation and set model matrix scale.
You have them commented out in model matrix.
Yeah, I have them in, yes, I have them here though. So I'm going to see if we can do this. Like so. See if this still compiles, if I haven't ruined too much around it. I get a null pointer exception on. Okay, if I'm not going to get this graphics environment here, just put them in here again then. Take them out of here. Graphics environment back on.
An error in graphics environment.
Okay. Okay, so it's using values that I've commented out. Okay, this is a null pointer exception. I'm not going to fix this. I'm not going to waste time fixing this. Instead, I'll just throw these out then. Okay, they're using, the point I was going to make is that if I use these functions and I set the translation, I'll set it to a point, a particular point. If I set it again, what I was going to try to do was I was going to make a change here, like put it to 1, and then just put it to 1 again, and put it to 1 again, and it'll never change. All right, it'll just always be setting the translation to 1. It'll just be setting the point there. And then I was going to show you that no matter how often I call it, it's going to give the same result. Same with scale. I could have just set the scale to 2, 2 and 2, and everything would grow by 1. So instead, let's start with a scale. If I do no scaling here, it looks the exact same. I'm going to scale everything by 2. So I'm simply adding a scale to the model matrix.
Because you're only working in 2 dimensions, you leave the last one as 1, correct?
I leave the last one as 1. I can put anything in here really in the last one.
Okay.
I could even put 0. It'll just make everything 0. Because in my shader, I'm kind of wiping out the z values anyway.
Okay.
So the last one I'm just doing more or less nothing with. But if you want a neutral value for scale, that value is 1. If you want a neutral value for translation, that value is 0. All right, so I'm scaling here by x and y, double. Okay, so everything's bigger now. I can try to scale only on the x. All right, so I add this scale and then I draw all of these things. I don't remove that scale again. I just add it once and then I draw all of those things. The point earlier where I could have called the same function as many times as I want and I just get that scale. If I now scale it twice and then scale it twice again, it actually scales twice again. And if I scale it twice again, no, I've scaled it 8 times now. If I scale it twice again, because I'm adding the scale within the current transformation that I already have. So now I've, doubled it once more. Same with translations. If I say let's just have this scale here double. I'm gonna add a transformation, a translation, and I'm using this variable here, position X and position Y. Let's just look at that. I have the 0.2D position. You can just see 0.2D here. It looks like that. You can pause the video if you want to look at it in more detail. 0.2D position. And what I've put in here is simply 0 and 0. So fine. 0.2D position, this will change nothing. If I now, let's say I put the value 5 in here, you can see my window actually. My window is from -10 to 10. So it's not pixels really. If I put in a number like 100, then it'll just disappear off screen. The window I'm working with now is just from -10 to 10 in both dimensions. So putting a number like 5 should take something like a quarter to the side of the window here. It was in the center, now it's over here. If I add that translation again, you can imagine that we simply always save. No, that translation is added again. It's exactly the same result as if I were to either do this 2 times here, or if I were to just do position X and Y, but change the value of position X to 10. These things add up. Another thing, if I were to skip the scale, or no, more interesting, let's put this back to 5. And I do the translation first and the scale second, I get this here. If I, however, turn it around and do the scale first, translation second, the translation happened in the scaled coordinate frame, and so the translation is double as well. Makes sense? I grew my coordinate frame first, and then I translated within that bigger coordinate frame, and so the translation becomes bigger as well. Now we can see something like model matrix dot main dot add rotation Z. Rotation Z is really the only one that has any effect in 2 dimensions. Rotation Y might, but it more look like a scale on the Y than it would look like. Let's keep this simple and just say, let's say 30 degrees. And so now we've rotated that there. Again, first we had our coordinate frame positioned here in the center. Then we made that a little bit bigger, and then we translated by that to here. Then we rotated. So it already had a center here when we rotated it, so it rotates about this point here. If I put the rotation in earlier, before I do the translation, it's up there. Because I started out here, then I scaled it, then I rotated it here, which means one of its axes is in this direction, the other one in this direction. So when I translate, it's not translating to here, it's translating along this changed axis. Make sense?
Yeah.
All right. Particular things you want to see before the break. After the break, I'm going to kind of put motion into it and make all kinds of things and add things to the whole idea. But are there particular things you'd like better explanations of at this point? Do you feel all this makes sense? Is this too elementary? Do you like to actually see this, or am I just wasting our lecture time? All right, cool. So what I want to do after the break is I want to kind of add motion to this, add changing variables, see how we can make things rotate over time, how we can make things move over time, and using these transformations particularly to do that. Seeing how we can, like we're doing now, we have actually a lot of things. We have the solid circle, we have the box, and we have another circle. And we're drawing all of them after we do the transformations. We can look at what happens, for instance, if we only add the translation after we've drawn the first two, but before we draw the last one. What did I forget? Why didn't this affect anything?
You didn't set your shader.
I didn't set my shader matrix or the matrix in the actual shader. So this function, if ever you make a change to the model matrix and then you want it to have an effect, you have to add this. The reason I have it separate, we could simply in add translation also put it directly into the shader. Sorry. The reason I have it separate is that sometimes we want to add multiple transformations without drawing anything in between. So then we add all the transformations, then we set that matrix. Then we have a ready-made combined matrix. We set that.
Like you do your add scale and add rotation, and then send it to the shader instead of
exactly.
Scale, shader.
Yeah. This would give us the same effect, like after every transformation to actually set it into the shader, but it would be pointless. It would just be sending extra data to the graphics card kind of over the bus of our computer without really having any need for it. It's not going to slow your game super much down, but every optimization is good. So now we should see the effect of this. So you can see this was scaled, then rotated, then we drew these two things. Then we translated to here. We can do the same here. We can see them actually, see each of them and their effect. Like so. Separate these things and see the first thing that happens. Okay, it's hard to see a scale on a rotation on a circle, but it doesn't really matter. Either way, you get the drift. So we can play around with this. We can make lines, we can make more boxes, we can kind of make these combined things. The way we were doing it earlier is we simply said each of these transformations here, we did all of them together, like so, in some order. Did all of them together. Then we drew all of these things, so they kind of become one model. And every time we add a transformation up here, the whole model is affected by it, both the circle and the box. And this is what we do when we have a combined model. We add a lot of different stuff. But let's look at a different thing after the break, which is if I have a model where some parts of the model also need their own transformations in between drawing of them, then they need separate transformations that I then need to undo between drawing them. But also, if I want the whole thing to get bigger or the whole thing to move, I can still add transformations before I do the whole thing, and those will affect the entire model. So these kinds of things after the break. For now, let's take 5.
You said that the matrix class is on Canvas, but not the model matrix class, correct? Okay.
Yes. So matrix class is there with all the base functionality and just calculations and stuff. But adding the actual rotation, scale, and translation, and getting the vectors and all that, I'd like you to do that yourself. I do it in one of the videos though, so you know.
Right.
I just want everyone to kind of get their hands into doing that.
Makes sense. I was,
even though you end up following a video and just doing the same, it's still
you're still typing it. It's like writing.
And you know it's there.
Yeah.
It's not just something that's hidden for you. It's not black box anymore.
Yeah, I was trying to do like a similar thing without having it be different classes, and it wasn't working correctly. So I'm actually very happy you're doing this because it makes a lot more sense.
Yeah. Even
just after the first half of class, it makes a lot more sense to be able to understand what I should be doing and I'm not doing.
All right, that's good. That's nice. And often it's nice to just see this happening in the program, even though we're not adding any special knowledge. We're just adding the connection of what does this look like? And it
and
often just solidifies it.
And sometimes just simple example code, like even if you had to take that like simple code and make it more complex to do what you want it to do, just having like the baseline or seeing a baseline is really, really helpful, because then you can go from there.
Yeah. And just make sure to make small changes and look at them every time.
Yeah.
Don't write 10, 20 lines of code all doing different transformations and then and then hit play, and if it doesn't look the way it was supposed to, it's like, which one of these numbers?
So which one of the 20 translations I just did is messing with it?
Exactly.
And you're gonna do like put a translation on and then take it off after.
Yeah.
Right? Okay.
I'm gonna work with the push and pop matrix thing a little bit.
Sounds good.
After the break. Yeah, and add a few, and maybe save an intermediate status of the matrix, continue, pop back to there, continue from there in a different direction, pop back to there, all the way back, continue from there.
Cool, like yeah. That would be awesome.
Classic planetary system idea is very good to explain these kinds of things. You go to the planet, you rotate it, you go to the moon, you rotate that.
Yeah.
And then we go back from somewhere, you don't want to go all the way back to the central, it's just back to that planet and continue. Yeah, the rest of the stuff around it. Is it cold enough already in here? No. As soon as I close the window, it's going to get stuffy.
Yeah.
I can't imagine what it's like if we're completely full.
Is there a good way to add text to?
I answered that one on the outside, actually.
Okay.
Yes.
I saw the answer. I didn't quite read it all the way through. I just kind of skimmed it.
The idea is you can add text fairly easily using kind of higher level libGDX functionality. But then and I'm okay with that in this project, but it's like a little bit outside of the scope or something. It's not too complex, but you can't do it really instead of other stuff. What happens is that libGDX will then switch to its own shaders, because you have a certain shader program and you link that to OpenGL. And when you send in variables and stuff into the shader, you're sending them into that shader program. When you ask libGDX to draw text or draw sprites or something, it'll switch to its shaders, which means that as soon as you're done using that functionality, you have to call code to switch back to your shader, which is basically just the function GLUse program with your rendering program ID. But that just means you have to make sure that you have access to the rendering program ID that is made in the create function.
So finding a way to like symbolize what I would be writing in text is probably a better idea.
I usually recommend that. To just say, if you want points, you don't need text. You can use different sized boxes, or you can use check marks or lines or stuff.
Yeah, it was you doing the cannonball thing. And I was gonna try to make it so you only can use X number of lines.
Yeah.
So then as I was talking, I was like, so my initial thought was like write the lines remaining and then a variable number.
Yeah.
But if you just have just draw lines. Yeah.
Draw a bunch of lines, and each time you use one disappears.
Yeah.
So I recommend just doing these things graphically because it's just fun and creative to figure out ways to make a visual interface, a user interface without being able to use text or numbers. But then again, using text and numbers isn't that complex, but you're basically just using a higher level libGDX functionality. It can add a lot to your look of the program, but it doesn't add a lot to the kind of intrigue of the project as such.
Yeah. That makes sense, yeah. So I can do that easily. Most need like a README file before the start of your game so that you can explain, okay, so here's your rules and here's your symbols. So you have this many number of lines, and it's
as soon as
you have a how to
play.
Yeah.
As soon as people start going outside of kind of the exact way that it's supposed to be played, it's nice to get a little bit of how to play or a readme.txt. I also encourage people if they just implement interesting things into the game, and maybe interesting things that are interesting in code but you don't really see on screen, like the way you do your collision, if that's super interesting, or something like that. To actually just make a PDF and return it along with the project, where you explain these things, explain the methods that you use. So if you have something that you want to be taken into account when I grade it, tell me what it is. Because some things I can notice, things that are actually graphical and are happening in the game I notice, but things that are happening in your code can very easily go unnoticed.
Yeah.
So if you're super interesting,
optimize something or something
yeah,
like
you
that.
optimized something, or you had a really interesting way of doing your collisions, or kind of did them in a way that was mathematically super correct or something like that. Or the way I was talking about, kind of you hit a collision and then you kind of take the remaining time of the frame and you kind of extrapolate to there and see if there are more collisions there and stuff. I don't expect everyone to implement it to that point, but if someone does, make sure you let me know, because maybe I don't see it by just running the program. So let me know, make a little PDF, make a little report along with it and say, I did this, I did this, I did this, these are the rules of the game. I want a good grade here because I put a lot of work into this. But
notice me.
Usually, once I always just told people you have to do this PDF and you have to add this, but in some cases people just did exactly the way it was, nothing especially extra. Nice project, nothing extra, and that's fine. But then really the report was nothing except, I just did this stuff. So it's okay to skip the report if it's very basic, or if it's just exactly the way I describe it and you're not doing anything kind of outside of that, fine, skip the report. But do a little report, do a little PDF and add it to it if you're adding something of interest like that. I'll put that on Piazza as well, just to remind people that they can do that. All right. So where were we at? Looked like this. This seems to be first, like out of the translation, scale, and rotation. In which order do you imagine it is now?
Translate, scale, rotate.
Yeah, it's probably the translation first at least, because otherwise it was translating all the way to the screen. So it's translating before it's scaling. It's also translating before it's rotating, because otherwise it would be translating diagonally up. Scale versus rotation, we don't really know.
Doesn't really matter.
Doesn't really matter. Well, it can matter if I'm scaling not the same on X and Y. If I'm scaling the same on X and Y, it doesn't matter if I do rotation and scale first. However, it can matter if I'm doing it the other way around.
It's rotating and scaling.
It is rotating and then scaling, but
I could just do one that's scaled and rotate and change the values and then switch it back.
All right.
Out of curiosity.
Let's see what this looks like.
Oh, okay. Makes sense.
Okay, can you see what happened there?
Yeah.
Let's do it the other way around. Let's do the rotation first, scale second. We rotate it, but it's kind of keeping, it's still right corner, it's still 90-degree corners there. However, when we did the scale first, and we kind of scaled the axes to different lengths, and then we do a rotation within that, we kind of get this weird diagonal shearing type look, and it's not 90-degree corners anymore. So just generally, if you have scaled something where you have the axes in different sizes, you really need to know what you're doing if you're going to do a rotation after that. So I'd say, in general, it should be translation first, rotation second, scaling third.
Unless you wanted to rotate and then translate.
In some cases, you want to rotate then translate. But let's imagine each kind of object has its own position, orientation, and size. Then maybe that object is part of a bigger overall object, which has its position, rotation, and size. And so you might end up rotating and then you translate for another object. So translations can be added on top of rotations. However, for a particular object. Like let's just say this here thing is a particular object, and it has a position, it has an orientation, which is now 30 degrees, and it has a size, which is now 2. Then I would do it in this order. Position first, orientation second, size third. However, like we said earlier, we might be doing different things there. So one of the things we can do, and it's very nice to do early on when you're working with something like this, is to kind of encapsulate things in classes. So making a class that is this object and that knows how to draw itself and it knows how to move itself would be a nice thing to do. Let's look at that a little bit later though. So for now, we're imagining this is kind of this single object here. Let's add a little bit of variation to these things. So for instance, here I have a position and I have what I call a motion, which could be called speed. For now, that's set to 0. So let's change that a little bit and say, I am going to say that this moves 1 unit. And remember, my screen is not 20 units wide because that's the window I'm working with at this point. I want it to move by 1 unit in the x dimension per second. So I've added 1 here. 1 unit per second is now my speed. So my update function is suddenly doing stuff. The first thing I do is I take GDX graphics get delta time, which is basically a value that that libGDX keeps track of for me, which is how long since the last frame was drawn. So how long did this frame take, or the last frame take? And then I'm going to say, to the position, I'm going to add the motion times the delta time. We could do this as vectors. It's just the position equals the position plus the motion times delta time. But I'm doing it in x and y separately here. So that's all that's happening. This means that every single frame, the position is being changed a little bit. So let's make sure the position just starts at 0. And let's see what effect this has. Okay. So this is changing like that. So now it would be more interesting to look at what happens if I do the rotation first, for instance. It would be moving at the same speed, but now it's moving diagonally upwards. If I do the scale before the translation, again, it'll be moving diagonally up, but it's moving twice as fast. So it's moving faster. All right, we can take another thing. We can say, let's change more things here. Have a position. Let's make a variable that is the rotation angle. So let's take rotation angle here and begin with it at 0. Then we can go in here and say, all right, our rotation angle. Now I could also have a variable that's called rotation speed, so I can see that changing. Let's stick to the rotation angle for now. Rotation angle plus equals, so it's degrees, let's say 180 degrees per second. So that's times delta time then. And then instead of 30 in here, we put rotation angle. It'd probably be cooler if we were rotating the other direction. All right, so now the rotation is changing as well. Could make it look like a wheel if we really get into this.
It's a wheel going backwards.
Yeah, so we can do minus 180 here, And then we can say, well, let's make the speed a little bit faster and see if we can make it look like actual wheel. Almost. All right, so we've got something going here. What more could we put in as variables? We could put size in as a variable. Object size equals 3. Object size. So object size equals 3. And add scale, object size, object size. So now this, then we can go ahead and we can change that. We can even start with object size equals 0. Go ahead and do object size plus equals what? Maybe something like 0.4 times delta time. Stuff happening now. We could go further and we could go ahead and say something like object size, not plus equals, but just equals. We have math dot cosine of rotation angle. Let's change that to, so it has to be, okay, times divided by 180 and change it into double. Like that.
And you need to cast it as a float. As object size as a float.
So
To cast
cosine takes a double, right?
and returns a double.
Yeah, then I have to do float on that. Yeah. My battery. Okay. Okay, so bunch of interesting functions here. If we don't want it to become completely tiny, we can instead do something like object size is 0.5 plus this. We'll never go into absolute weight.
It becomes negative.
Because it becomes negative. Yeah. Okay. Yeah. Then we can do an absolute value of that. Sure. I mean, okay, we can just play around with this, obviously, and have fun with that. What's my error now? It's math. Math dot absolute. Fine. So while we're watching that, okay, one thing I'm gonna add before I plug my computer in, before it becomes completely battery less. We can go ahead with the position and we can say if position dot x is greater than
no width.
Yeah, it is like 10. Let's just put it to 11 or something. That's fine. So position dot x equals -1. No, -11. We should just be able to run it endlessly while I go ahead and plug in my computer. Old school. Fancy. Now it's just like watching a candle flame or watching waves or something. We could just run this forever and ever and never get tired of it. Put this in there. It's closer, even though there is one on the. It is. This is the best one I've made yet. Better than the spaceship one. All right, all right. Let's not waste all our time. Waste all our time on this, because what we can do now, and I'm going to just do that real fast here. New class. And let's just call it rolling thing. Let's just leave it at that. Okay, so we have rolling thing here. I'm going to go into game here, and I'm going to take all of these variables that we had here. I'm going to see if we can just throw them into rolling thing instead. Then in rolling thing, like in any object that we're going to make, it needs to know how to update itself, and it needs to know how to display itself. So these will always be the first two functions that we make for a class like this. So void update, and I would like to add a variable here, which is delta time. So delta time is controlled by outside factors, but we can send them into any update function. So the main update function finds delta time, or in our case, just asks libGDX for it, and then it sends it into the rest of the update functions. And we'll have a void display for this particular function. Okay, so let's go in here and say we're gonna take all of these, which have no point in here anymore, go into rolling thing, and we're gonna make a create function. Now let's just make a constructor, which is, it's not void, it's just the name of the class. And it's public, yeah. That's the Java. Oh. Yeah, just regular parentheses here and more than doing. All right. So constructor here. Then we go into our update function and take all the stuff that we're kind of doing here. Throw it into this update function.
And we want to make sure we construct rolling thing.
Yeah. So we got to make sure that in here, in update. So let's just start by moving all the stuff out here. So we are going to take these rotations and this drawing thing here, and we're going to take all that out. So the clear color and the GL clear and the load identity, those are still part of the main display function. Our personal display function, however, will have our personal transformations and this stuff. So now we need to actually go up here, and instead of the variables that we took out, we're going to make one rolling thing. Like so. In our create function here, where we made all the variables, we are now going to construct that. So in our update function, we're going to make sure we call the update function for rolling thing with our delta time variable. And in our display function, we're going to call rolling thing dot display. Nope. Rolling thing dot display. Other errors? Oh, still works. So now we've simply taken our code and we've moved it into a function, or into a class. Okay, so it does all the same things. So this rolling thing here. Okay. So let's make the rolling thing a little bit different now. And probably in the end, we'd like to be able to send variables into rolling things, so we're not just always using the same values. But I'm gonna skip the motion for now, and I'm gonna skip the rotation angle change. So then we'd maybe add something like rotation speed. Say rotation speed equals 0 as well. And then instead of this, at rotation speed. Okay, now we made it 0 though, so everything should be just still there. So let's make this object a little bit different. Let's say we don't want it to be a circle with a square in the middle anymore. We want, let's say, 4 different squares, like they're wheels on a car. So I want to say, I'm going to take the box here. I'm going to do that a little bit differently. We're going to add a translation to that box. And that translation is going to be to start with 1, 1. 1, 1. And then we're going to set, find this color. And then we're going to draw the box. See if it draws. What did I forget? Let's just set the color beforehand, because that's going to be for all the boxes. So do the color, and do the translation for this one. And hopefully it's kind of, okay, it's outside there. Fine. Now let's make 4 of those. 1, 1, minus 1, 1, 1, minus 1, and minus 1, minus 1. Okay, what did I do wrong now? Where are they being drawn?
You never went back to the circles.
Yeah, I never
field.
went back to the center. So I drew one here. That's the first one. Let's just look at the numbers. 1, 1, I went to here. Minus 1, 1. That's minus 1, 1. I went to here from here instead of going to here where I wanted to go, because I'm already here. Minus 1, 1. Next I go 1, minus 1. 1, minus 1, so I go back to here. Then I go minus 1, minus 1. So I go, so the first one is here, second one here, third one here again, fourth one here. That's not really what I was looking for. So what I want to do now is I want to say, okay, I'm here at the center, but I want to save that position. And more interestingly still, let's go into the lab 1 game. And before I draw the rolling thing, I'm going to say, I want this rolling thing, steal this translation here. I want this rolling thing to be positioned at something like 3, 5. So the center of it, I want to be there. So it starts here, but it's still the same image. That means I can't go and simply clear my model matrix. I can't call model matrix.loadIdentity, because that would always take me back to the center. And my rolling thing doesn't know that this translation was added. This is something that the display function knows, because it's the kind of parent function of the rolling thing, meaning I can't, I have to take into consideration that the display function may have done stuff to the transformation matrix before I got it. So what the rolling thing does now is that after it set its color and stuff, it goes ahead here and says, all right, model matrix main dot push matrix. So it says I'm going to take the current matrix, whatever that is, and I'm going to push it on top of a stack.
Don't you want to do that at the very beginning before you do any translation or rotation or scale, so you can return it to be the same place it was when you got into the function?
I would also like to do that, yes. So, all right, let's do that at the very beginning. However, if I have a specific position and a rotation and a scale here, that's kind of where the center is. So because of that, I kind of need to do it here as well, right? Mm-hmm. I need to make sure that that's with it as well. So, okay, doing a push matrix at the very beginning and a pop matrix at the very end is a very good idea. Just to make sure that whatever I started with will not be changed. I save what I started with and I load it back in here. However, at this point, I'm also going to save whatever happened after I went to my position, so on and so forth. For instance, if I add some motion again and say the motion is now something really slow here. 1. No, it starts up there, but it's moving from there. I want the whole thing to move with it. So now again, so now I push the matrix here. So in order to save this, then down here, I'm going to go ahead and I'm going to do pop matrix. So whatever I had before I did this translation and drew this, I now have that again.
You don't have to push again because you're back where you were when you initially pushed, correct?
Now I need to push, well, I am back where I was. We can actually do it just one time and see what happens then. So, okay, suddenly it's a little bit different. I start with this one, then actually go back to here and go up to here. But after that, same thing happens. I just go all along. Someone believes that they're calling my office, and they're actually standing outside the door of the computer science department. That's what that number means. So someone is trying to call me at my office, standing outside of the computer science department, but alas, I'm in class. Okay, so I pushed the matrix to save what I have here. I changed it. I popped it to go back to where I was. At that point, because I'm going to do more changes, I push it again. And then down here, I pop it again. Push it again. But do a lot of pop matrix, push matrix. Do that whole thing here. Does everything match now?
You need to pop one more time.
I need to pop one more time, or if we exactly know that this is everything we're going to do, we could in fact skip the last push and say, okay, this is the last translation. It'll just go away when I do the final pop, whatever. Or I could do an extra push and a pop. It always looks cleaner to do it that way. However, what we will get now is at least we'll get them in the correct positions. What if I want them all to be smaller?
You want all of them to be smaller?
I want all of them to be smaller, but I'm very happy with the position I got them in. So I don't want them to be in different locations. I want them to be exactly where I put them, but I just want them to be smaller. So if I want all of them to be smaller, it seems like a nice idea to go ahead and do an extra scale here. Say, okay, I'm going to draw the first part, which was the circles. Then I'm going to say, okay, I want this to affect all of them. So I'm going to put it here. I'm going to put a scale, and I'm going to put a scale to 0.5, which is my kind of my tire size.
You're going to be changing their location.
I'm going to be changing their location as well, because they're not moving as far out. So what I really need to do is I need to take this scale and I need to add it after the translation to each of them. So that just becomes part of the draw tire function. Okay, now I have them in the correct locations. Maybe we'll want a little bit of rotation on each of them, like all of them to tilt a little bit inwards. Do I have to do it separately with each? I kind of need to. Yeah. So maybe I could go into rolling thing and say, okay, this is getting complex. I want to have a draw tire function here. On a private void draw tire.
Probably takes in 2 variables.
It needs to take in the variables with their locations.
So X and Y.
Yeah. So let's say float X and float Y.
Wouldn't it also need the scale and the angle? Like these.
The scale is probably the same on all of them.
Yeah.
So maybe I can skip that as a variable. But if I want them to tilt like inwards and inwards, then I'd probably need kind of the rotation as well. Like 2 of them should rotate this direction, 2 of them that direction. So we could go ahead and say float rotation, something like that. Am I already using that? No, I'm using object rotation.
And you want a local variable that's the size of the tires, the scale.
Yeah, or I can just hard code that in the way I'm already doing or something like that. So what I need to do here is I really need to take one of the pushes and one of the pops, and say, okay, this tire can draw itself, and it'll just start by pushing, then pop. It'll translate to X and Y. X and Y. It'll scale to the correct size, and I can just hard code that since it's not a variable. Then I'm going to, well, before that, I'm going to rotate. So we can add a rotation here. Just steal that from here. And we could actually go ahead and say, do I really need the rotation here? Or is it more like I just want to know in which direction? So I could just call this int rotation direction. It's either -1 or +1.
Int float.
So then we can do something like
You have int float in your.
int float. That's not a thing. So then I can instead just say, okay, this is going to be rotation direction times whatever I want it to be, 25 degrees. And we can do something like this and say, okay, now I have a function that will translate it to the correct location, but that location is like a local location on the car or whatever that I'm drawing. It's not a global location. I can add the rotation, which is basically it's telling me either it's going to tilt to the right or it's going to tilt to the left, depending on which wheel it is.
Or 0 for not all, right?
Yeah, or I could basically affect it in any way here. Yeah, I could also put in grades or something. I could put in a Boolean and have an if sentence and something, but either way, you know, this is always just my decision. I'm programming this, I do whatever I want. I could put the whole number in, I could make a scale factor, whatever. I'll just put a little factor there. And I'll just have the scale hard-coded for now. I could also go up here and say, let's make a separate tire size. Let's say I want, why did this not, oh, I guess this was not connected. So we'll go to here and hope this is, yes. Okay, let's go to tire size here. So tire size. And just go in here and say tire size equals 0.5 it was. I'd like them a little bit bigger, 0.62 or something. We can take tire size, stick that in here instead. Well, all kinds of factors and variables we can put in here. All right, and we could put tire rotation as a variable as well instead of 25.0. But I'm gonna stop boring you here with this. Now I'm gonna take all of this out and say, okay, all the tires, I just have a function for those. So now I'm just gonna do draw tire. Now the first one I'm gonna put at 1, 1. And I'm gonna tilt it by 25 degrees. So I'm just gonna put 1 here, 1, 1, 1. And I have 4 tires. 1, 1. I'm going to put one at -1, 1. That's going to be tilted by -1. Then I'm going to put one at 1, -1. That one's going to be tilted like this as well. And this one. Okay. So I have them in different locations. Some of them are tilted inwards, some outwards. Let's just make the tilt a little bit less, 15 degrees. All right, so we have that there. If I now want to add a rotation, say I have some rotation speed here, like let's say 60 degrees per second. I imagine we already had that. Okay, let's skip the whole object size thing here. Say object size equals, just say 2 here, have that fixed. Now the whole thing is rotating. So I have this image here, the whole thing is rotating. Maybe I want the circle, let's take the rotation speed out for a while. Maybe I want the circle to be a little bit elongated, like in this direction. I want it to be longer here than it is here. Need to take the speed out as well, right? So how I'm going to do that? Let's look at the image. I want this to be elongated, but I like the position of the tires. I just want it to be a little bit taller, the circle, and a little bit narrower, so it kind of fits within those nice looking tires.
Going to be into that. Yeah. But
I need to scale it a little bit more in the Y
Direction, but
than in the X. Okay. So that's going to be my scale. Let's imagine I'll just hard code those numbers. I need a new scale. The object size I want, because I want to be able to make it smaller and bigger. And I want to be able to make big cars and small cars. And, you know, if it suddenly doesn't look right on the track, I just want to change one number and the whole thing gets smaller and no other dimensions change. So where do I put this extra scale that I want? I can imagine that somewhere before this here is drawn, I'd like to, let's say I want to narrow it a little bit down, so it's going to be 0.8 on the X, but I want it longer here, so it'll be like 2.2 or something. What's going to happen now if I add this at this point?
Make the 2.2 afloat.
Yeah, need to make 2.2 afloat. What do you expect to happen?
the whole thing will be low.
Not the
You're gonna
location,
scale the
yeah.
tires as well.
Yeah, okay. So the whole thing got stretched. So that's not what I was looking for. I want the tires to still be in the same spot. So what can I add now? I've got everything I need. I just need to add what? I need to add a way to take it away before I do the tires.
Right, so you need to push
So where am I going to push?
before it.
Yeah, but before only this.
Yeah.
I don't want to push before this because then I'm taking this up. So I want all this to still be in effect because this is the main overall size, orientation, and location. But this little thing, I want to only affect this part of the drawing. So then I simply say, all right, I'll make a push and a scale. And then after I do this, I'll make a pop. So I push what I have here, so I save that. Then I add a scale, I draw these things with that scale, then I pop, going back to the last push, which was before I added the scale. So the only thing that has disappeared once I pop this new version is the scale that I added here. And you can see it doesn't matter when I do the shader matrix thing. I just need to do that every time before I draw something. Otherwise, I'm just working with the matrix, and I'm just working with it in my own code. In this here model matrix class, which is my own Java code and has nothing to do with OpenGL. It's just my own math. Also nice to remember, you know, some things we're just doing ourselves in our code. It doesn't have anything to do with OpenGL until we take the values and actually send them into OpenGL. So at this point, all right, our tires are where we put them. I wouldn't like the car to be quite so wide and long, but you know, the correct things are happening here. So we can go, sorry, I'm in the wrong class. Go back to rolling thing. And we can say, okay, this was a little bit too much. Let's set this at 1.8. This was also a little bit too much. I want it to be even narrower. All right, so something like this. Then I might look at it and say, okay, it doesn't look like the tires, or it's not tires anymore. No tires are like that. I'm gonna imagine it's a hovercraft, and you know, these are really coolly angled things here. I just want them to angle a little bit less, so they line perfectly up here. And then we can just go ahead and you know, experiment until it fits nicely or whatever, something like that. So here's my hover car. If I now want to rotate the whole thing by adding a rotation speed here, this should rotate the whole thing unchanged. So my entire model is a combination of a lot of things, but making sure that the rotation I'm adding now was added before everything, it'll affect everything. Then I use the push and pops to make sure, okay, this rotation affects some of the stuff, but not all of the stuff. This scale affects some of the stuff, but not all of the stuff. So to summarize, these things here affect the whole model. This scale here only affects the chassis of the car. And these here, rotation and scale and translation, only affect the tires of the car, or the hover units of the hovercraft.
It's only affecting one tire at a time, correct? Because you're recoiling every time.
Yeah. So these are only affecting one tire at a time. And I push and I pop beforehand. So the tire function itself is made in this way that we want all drawing functions to be. That it will leave you with the exact same model matrix as it got from you when you called it. So we call it, we start with a push, we end with a pop. In this case, we have a lot of pushes and pops, but if you can make sure that you match them up one for one, you start with a push, you end with a pop, and then there are the equal amount of pushes and pops in between, then you can be exactly sure that whatever model matrix the global function had when it called you, you haven't ruined it. You've left it again in the exact same state as you got it. So that's kind of a key thing here. So we have the rotation there. We can add the motion again. No, add the motion and make it fairly fast. Okay, so this looks like ridiculous motion. Then we can start doing things like, okay, I want some kind of orbit motion or something. Then I need to do a rotation first and then a translation and then the rotation. So if we go ahead and do that and say, okay, let's not have a motion here. Let's just have the position at X at 5 or something like that. Let's go into Lab 1 game and take out this translation here, so it just starts in the center. Yeah, I'm just about good on time. So, but we're gonna skip, well, 5, I don't know, 5 is fine. But we're gonna skip the rotation and the translation. It's gonna look like a car kind of driving around that center. Again, each object should have its own position, orientation, and scale, and in most cases, we'd like to do the translation first, the rotation second, and the scale last. But then you want something like an orbital motion or something like that, so you can add before that as well. Like, okay, now I'm doing the rotation first and then the translation, meaning I'm always translating along a rotated thing, and then I get this orbit motion. I'm pretty sure in one of the videos I make like a planetary system, but not with circles, like with little drawn coordinate frames, like with 2 vectors actually drawn out. Because if you have circles, you don't really see the rotation. And then I basically add a bunch of kind of planetary rotations, like translation, rotation, translation, rotation, pushes and pops in between. So I can make one the center, another one a planet, moons around that planet, and kind of pop back to make the next moon, pop back to make the next moon, pop all the way back to go out and make the next planet, so on and so forth. You know, you can just definitely experiment with this. Go ahead and get this going, this model matrix, make it work so that it works like I have it. And if we just sat here for an hour more, we could just throw these things around and just make all these kind of different effects and stuff, and it'd be super fun. So I hope this is at least enough to kind of yeah, act as a catalyst to your minds for all the stuff you can now do in your program and play around with the transformation matrices. Again, using the transformation matrices in this way is not necessary for the programming assignment you're working on now, the 2D game, but it's very nice and it adds a lot of dimensions for you to be able to use it. But you can finish that assignment with just the original set translation and set scale functions that I already have there. So thanks, time's up.
You said you're gonna
have a nice weekend.
You are recording this?
I'm recording now.
So you're gonna post
your voice
it
is
on,
being recorded at this moment.
Cool. So you're gonna put it on Canvas.
It's already on Canvas.
Okay.
It's been live on Canvas this whole time.
Huh, cool.
Or live on YouTube actually, but the link to it is on Canvas.
Okay.
So yes, it's on Canvas. I'm pretty sure it's published. I can just show you where it is after I stop the recording.
That would be great.
Any questions that you want on the recording? If not, I'm going to stop the recording and